Was there any big news from the weekend? Big news? We got a new couch. We've been looking for a couch for like 2 years. Yeah, we've been looking for a couch for 2 years, and it's like, we're not real picky people, but we go to these furniture stores, and it's like, the couches are ugly, or they're uncomfortable, they're all for like, they're really big or whatever. But we went to, this isn't an ad or anything. This was just sort of blew us away. We went to, y'all don't care about my couch? We went to Louis Mohana down in Berg. That place was huge, and they had like 100,000 square feet or whatever. The rooms kept going and going and going. So we got a couch. It's actually a lot, like, we're pretty simple people, but it's a lot nicer than we would normally have. It's a flex steel, which means that instead of having springs in it, it has solid bands of steel, and so yeah, she said it's a 20-year couch. Is that true? Okay, good. We want to have it for, really. It was a little, because it was like $1,000 for a couch. Yeah. Saturday? Oh, really? Yeah. It was fun. They had like popcorn out front. It was like a big party. All right. Let me just ask you a few questions, so get your clickers out. So as you go deeper in water, so as you descend, what's that? Oh, sort of recapping some of the stuff we did. The pressure A increases or B decreases. As you descend in water, the pressure does what? Does it A increase or B decrease? Good morning. I'm going to start writing the next question. Go ahead and click in on that. Which of these is not a unit for pressure? Go ahead and answer in the first one. You can look at your notes. You can talk to your friends. All right, I'm going to stop the top one. So the first question, the one that's going now, is as you descend in water, what happens to the pressure? Does it increase or decrease? I'm going to stop this at 108. So go ahead and click in if you haven't yet. Oh, there was no C. Remember, this is for the first one. Yet. No, that was the first one. Just, you can click in on the next one. All right, so as you descend, the pressure does increase. Remember, like the bottle that went down deep into the water and it scrunched it up? All right, which of these is not a unit for pressure? So this is the second. This is the second one, yeah. These is not a unit for pressure. Still running the second question. The third question, which is not running yet, is which of these is not a source of pressure in a fluid? The second one is running right now. Which is not a source of pressure. Okay, the second one is running out here, which is not a unit for pressure. I'm going to stop it at 130. So 10 more seconds on the second question. Which of those is not? Very good. Very good. Let's see, have I told you the O Street joke? I have told you that. Okay. Why do people never go hungry in the desert? Because of all the sandwiches there. That's just because you got 100%. All right. And now I'm running the third question, which is not a source of pressure. Which is not a source of pressure. We have three sources for pressure. Which of these is not that? Yeah, really. More about the quiz in just a second. Which is not a source of pressure? That's the question that's running right now. Stop at 40 seconds. If you don't know, just guess. Remember, you still get credit even if you get it wrong. All right, good. Okay, the normal force. I just made that up. Well, there is a normal force, of course, but that's not what causes pressure. Pressures are caused by an external force. They're caused by atmospheric pressure, which is really just another external force, right? Atmospheric pressure is that column of air that's pushing down on top of us. And then there's a third source of pressure, which we're going to talk about today, and that's the interaction of molecules. You know, if you've had chemistry in high school or whatever, you've probably seen the ideal gas law. Ever seen that? Maybe. It was a long time ago. Okay. Well, we'll deal with that today. The quiz is today. It'll be just like, yeah, Destiny, I'm sorry. Can I see? I forget what it said. Yeah, that's going to be atmospheric pressure, the weight of the fluid. And that's what's the cause of atmospheric pressure. But you can also have a pressure that's just caused by an external force. That's like a syringe, right? You push down on the plunger and it causes a pressure. Or like your heart, when it squeezes, it causes an increase or decrease in pressure when it squeezes? An increase. And that's an application of which principle? Starts with a P? No, not. Yeah, it is sort of Boyle's law, but it's also Pascal's principle. That when I exert a force, it is Boyle's law as well. Very good. But it's also Pascal's principle. When I exert this pressure, it's felt all throughout the body. All right? That fluids transfer these pressures. Okay, so the quiz is today. All right, the reading quiz. It'll be 10 questions. You'll just write the answers. We'll do it at the end of class at about 10 o'clock. Okay. It's on chapter 2 up to page 48, as I said in the email yesterday. And then also the test is on Thursday. That test is going to cover all of chapter 1, but nothing else, or as well as the introductory material on, like dimensional analysis and on units and stuff like that. So I'll go through the notes on that. There are some questions online, those concept tests, and then also read the book, heavily from the book. I am trying to follow the book very closely. I think it's a pretty darn good book, actually. Y'all agree? Yeah. Yes, I agree. Okay. So it's going to pull heavily from the book. So I would read the chapter, take notes on it, highlight important facts. There are some problems in there that you might see. Although I think there are like 2 math problems, right? But they're very simple, okay? And as a result, we're not going to have any calculators on the test. But if you feel like there's a calculation there, that you might need a calculator for, you can just ask me and I'll just tell you what it is. But really, any of the math stuff is just, 10 divided by 2, 5 times 4, that kind of stuff. They're very, very simple. So I don't think we need to use calculators. Is that clear? You will need a Scantron form that looks like this. You can get them in the bookstore, or you can ask your friend or whatever. But you'll need one of these for the test, not for the quiz. Is that clear? You'll also have assigned seating. I'll put a seating chart out front by the door. And it was my intention to have a lecture time right before the test, but my wife said, so y'all can thank her for this, that it's a lot better just to have nothing but the test. So that was not my idea. So I don't want to take any. Talia? I think so. But it's her, not me. Like if it was up to me, I'd give you like 10 minutes for the test. And
I mean, if you want to review the test before, we can do that.
right. If you have questions, I'll be here early and you can ask me beforehand. All right, of course, I'm around, okay? I'll be around all afternoon today. And Wednesday, I'm out until about 10:30, but then I'm around in the afternoon. And then Thursday, I get here at 7. Oh, wait, no, I'm sorry, I get here at 8 on Thursdays. But y'all can come see me between 8 and 9. Any questions? The exam is a pretty big deal. I don't want to, build it up too much, but it's a pretty big deal for your grades, so don't blow it off, please. Yeah. Huh? There are 40 questions, but, most of those are pretty quick. They're, you either know it or you don't. All right? Awesome. Great. Okay. Let's see. We left off with the 3 different pressures. I think we had just left off with this, right? 3 different pressures: gauge pressure, atmospheric pressure, and absolute pressure, right? And we sort of had this example of a tire, and when you read the pressure on a tire, 35 psi, right? And that's what type of pressure here that you're reading, the 35 psi of these 3. Is it gauge, atmospheric, or absolute pressure? That's the gauge pressure, right? But it's not the absolute pressure. Like there's an actual pressure inside the tire that is 35 psi plus 1 atmosphere. And we know this because if we let all the air out of the tire, our gauge now reads 0. But we know that the pressure inside the tire isn't actually 0. Because 0 pressure would be what type of environment? A vacuum, right. And it's not a vacuum inside the tire. Okay? So we have those 3 different types of pressure. And the absolute pressure, which is what we're going to deal with next, the absolute pressure, is the sum of the first of those 2. The sum of the gauge pressure and the atmospheric pressure. Okay. I have a little clip I want to share with you. This is just about how they make pressure gauges. I just think it's interesting, frankly, how they make some of these pressure gauges and they calibrate them and all. It's not going to be on your test, but I think it's fairly interesting. You want to watch it? What's that? With the questions? Oh, yeah, that was from last time. Oop. Yeah, so this is just one of the types of air pressure gauges that they use to measure this gauge pressure. Let's watch this. It's just a few minutes long. So in general, when we measure things, whenever we measure things, whether it's a distance or a force or a pressure in this case, we're comparing one physical quantity to another. Like for example, when I step onto a scale, there are springs inside of the scale, and I compare the force of my weight to the amount that the spring compresses, and then that translates it into a weight. But what is the pressure being compared to for this particular type of pressure gauge? What is the physical quantity that the pressure is being compared to in order to determine the pressure? What's that? No, I mean, there's some physical thing that's going on inside the gauge that's moving the dial. What is that? It's causing the dial to move inside the gauge. This isn't for the test. It's just an interesting question, I think. We had that little pipe, right, that was in there. I forget what they called it, that tube. And when you applied a pressure to it, it got bigger or it got smaller, depending upon what the pressure was. And then that was attached to the dial. So, but the amount that that pipe moves is related to the amount of pressure. More pressure, then the pipe expands more and causes the dial to move further over. I'm not sure that y'all think that that's as interesting. That was fairly interesting. But, okay. Well, let's move on to the third source of pressures. Remember, the first was the weight of a fluid, The second was the external force. And now the third is the internal forces due to the interaction of molecules. So the interaction of molecules is a source of pressure. The interaction of molecules. So consider that you have a container of gas. Have this container of gas. There are gas particles inside of it, and those gas particles have a certain pressure. I want to ask you a question. What do you think will happen if I change some particular things? All right, so what will happen to the pressure if, number one, if you add more gas? Will the pressure A increase or B decrease? Does the pressure increase or B, does the pressure decrease? So if you add more gas to this container, what happens to the pressure? Does it go up or does it go down? So I'm physically taking more molecules of gas and putting them in the container. All right, I'll stop at 35, 35. Okay, very good. The answer is A. If I add more gas, then the pressure increases. Y'all have a one of those air mattresses? Yeah, so when you start putting gas, you have a little pump, and you fill it up, and it gets to a certain level at all one volume. But then as you add more and more gas, more and more air to that air mattress, what happens to it? Does it get softer or firmer? It gets a lot firmer. The pressure inside the air mattress is increasing. The volume is now constant, but you can still add gas, air into the mattress for some time, and that causes the pressure to increase. All right, so if you add more gas, the pressure increases. What if you increase the temperature? Does A, the pressure increase, or B, does the pressure decrease? If you increase the temperature, what happens to the pressure? Does it increase or decrease? We'll stop at 30 seconds. Guess if you don't know. Okay, very good. The answer is A. If you increase the temperature, the pressure will increase. Let's see, is there a good example of that? Can't think of one right off. Can y'all think of a good example? Okay. Okay. All right. Yeah. So if you have something outside in the sun, it'll get harder, more pressure. Thank you, Cheyenne. And then number 3, let's say keeping the amount of gas constant and the temperature constant, let's say that you increase the volume of the container. All right. Does A, the pressure increase, or B, does the pressure decrease? You increase the volume of the container. So I physically make this container bigger. All right. I'll stop at 38. 38. Very good. The answer is B. If I increase the volume of the container, that's going to cause the pressure to decrease. Or, likewise, if I decrease the volume of the container, that'll cause the pressure to do what? To go up. So think back to your air mattress again. Now, what happens if you lay on the air mattress? I'm increasing the pressure, but I'm doing what to the volume of the air mattress? I'm decreasing. I'm putting a big slump in the middle of it, and that causes the pressure to go up. So if I increase the volume, it decreases. But if I decrease the volume, the pressure increases. Now, all these relationships are added up into what we call the ideal gas law. The ideal gas law, in equation form, says this, that PV, actually, I think your book uses a lowercase p, so I'll do that. PV equals N times R times T. I'm not so much worried about y'all using this mathematically, but I do want you to know those relationships, that what happens to the pressure when you change various things like we had before. Well, let me just show you what these various quantities are. First of all, P is pressure. All right, we're going to use SI units for all these. So y'all remember the SI unit for pressure? The Pascal, yeah, so it's a Pascal or a Newton per square meter. V is volume. That's going to be in cubic meters. N is the amount of the gas. If you remember back in high school chemistry or chemistry that you might have had here, N is in moles, right? So N is measured in moles. I think that's abbreviated MOL, but I'll write it out, moles. R is the universal gas constant. It has a value equal to 8.314. Oh gosh, what is that? Joules per mole Kelvin. And then T is the temperature. All right? PV is equal to nRT. Don't worry so much about the equation, though the equation really does help you to remember these relationships. So for example, like I said, if T increases, that causes the pressure to increase. Like if I increase one side of the equation, the other side has to increase. If N increases, like here, that will also cause the pressure to increase. And then also here with V, if I increase my volume, that causes a decrease in the pressure. So on one side of the equation over here, if I make this number bigger, then this number has to get smaller. So you need to know about those different relationships between these, four variables: pressure, volume, the amount of gas, or the number of moles of gas, and the temperature T. Now, Boyles' law is a special case of this, and some of y'all said Boyles' law earlier. Boyles' law is really just a special case of the ideal gas law. And you know this, I mean, you know it sort of in experience, but it says what happens to the pressure, or how are the pressure and volume related if the temperature and the amount of gas are constant. That is to say that PV is equal to a constant. All right? So how it describes how the pressure and the volume are related with constant temperature and amount of gas. That's our N variable. All right? This goes back to our air mattress, right? Like if I lay on an air mattress, I have an air mattress here, and then I come and I lay on it. I'm not increasing the temperature so much inside the air mattress, If I lay on it, it causes a dip, and that causes my volume to decrease, and it causes my pressure to do what? To increase, right. So if you feel of your air mattress, we just got an air mattress, actually. That's why I'm talking about air mattresses so much. But it's a nice illustration of this, that if our volume decreases, then our pressure is going to increase. Because if you feel of other points on the air mattress, you'll feel that they're firmer, they're harder because of the increased pressure inside the cavity of the air mattress. All right? So go home and get out your air mattress if you have one. Most people around here have air mattresses, right? Y'all have one? Yeah? So get out your air mattress and fill it up, and then you can lay on it and get your friend or whatever lay next to you and say, oh, this is Boyles' law. You feel it's a harder pressure. Okay? So Boyles' law just says it takes the left-hand side and says that that's a constant. If V goes up, P goes down. If V goes down, P goes up. They're inversely proportional, we'd call that. Inversely proportional. This has a nice application, and somebody said this earlier. Actually, no, they were talking about, somebody said this with regards to the heart, that what happens when the volume of the heart decreases, right? What happens to the pressure? It increases. Now, that's not really Boyles' law, because Boyles' law only applies to what type of material? In the phases of matter, solid, liquids, and gas, Boyles' law applies to what type of material? Gas, right? It's the ideal gas law, so it only applies to gases. But you can think of it anecdotally as being true that when your heart constricts, that it increases the pressure. Now that's more Pascal's principle. Yeah. That's what I was about to say, actually, yeah. So this does apply physically to the lungs in breathing. Can I go down from here? So Boyle's law does apply to the lungs. Evan, right? Yeah, very good. So Boyle's law does apply to the lungs. So when you expand your chest cavity, this is a question I'll ask you. When you expand your chest cavity, is the pressure inside your lungs is that pressure greater than the pressure due to the atmosphere? Is it B, is it less than the pressure due to the atmosphere? Or is it C, equal to the pressure due to the atmosphere? So when you expand your chest cavity, you make your chest cavity bigger, and so your lungs also get bigger, what happens to the pressure inside your lungs? Is the pressure bigger than the atmospheric pressure? Is the pressure less than the atmospheric pressure? Or is it equal to the atmospheric pressure? Pressure inside your lungs greater, less, or equal to the pressure out in the atmosphere around you? If you're not certain, take a big deep breath. Expand that chest cavity. Okay, let's see. I'll stop at 110. Okay, very good. Let me ask you another question. Is a fluid going to travel? Is it going to tend to travel? This is related here. This is sort of what you need to think to get this answer. Will a fluid travel from low to high pressure? or will it travel from high to low pressure? All right, so this is a separate question. That is, will a fluid move from an area of low pressure to an area of high pressure, or will it move from an area of high pressure to an area of low pressure? And that's what's happening in your lungs, too, by the way. It's moving from either a low to high or high to low pressure. All right, 35, I'll stop. Okay, very good. So a fluid, either a gas or a liquid, will tend to move from high to low pressure. DJ. I'm about to go back to that. I just wanted to get this question in. So when you expand your chest cavity, what happens to the volume? It increases, right. So I can think about this in terms of Boyles' law. So when I expand my chest cavity, my volume increases and the pressure decreases. All right? So I'm causing an area of low pressure inside my chest cavity, and there's this really high pressure outside of my chest cavity. And so all that air that is outside my chest cavity is going to go rushing into my lungs because I've lowered the pressure of the air inside my lungs. And so when I breathe in, everybody breathe in. Are y'all breathing? You're not breathing in. Okay. When you breathe in, you make that chest cavity bigger, and that high pressure air that's outside of your mouth rushes into your lungs and goes down and does all the business that it does in your body. Okay? So when you breathe inside, the pressure inside your lungs is less than the pressure outside your lungs, which causes that atmospheric pressure to push air into your lungs. It's sort of like the straw, right? You're making a low pressure, and that causes that fluid to move up into that low pressure. Because fluids will tend to move from high to low pressure. Okay? So the answer for this first one was B. That when you breathe in, you make that volume bigger, and the pressure decreases. And that pressure then is less than the atmospheric pressure. This is Boyles' law. Right? And you make your chest cavity bigger, it makes the volume bigger, pressure decreases. Likewise, when you breathe out, what happens to your chest cavity? It gets smaller, right? And so if the volume goes down, the pressure goes up, and then your pressure inside your lungs is bigger than the pressure outside your lungs, and that causes the air to go out of your lungs. That's pretty cool, no? Yeah. Okay. They say that we don't breathe enough. Like we go sort of around our day just sort of half breathing. But at least a few times you got a big deep breath. Okay? All right. Let's look now at pressure in solids. This isn't going to spend a whole lot of time on this, but okay, so pressure in solids. I think I have, give me just a second here. Let me look in I think I have a figure I want to show you. Might not have brought it. No, I didn't bring it. I'm sorry. Okay. So which of these exerts more pressure? You can have a 1,000 Newton football player or whatever. That's a football player. He's a happy one. All right, 1,000 Newton football player. Okay, I'm not a very good drawer, but y'all get the idea. 1,000 Newton football player, or you can have a 500 Newton ballerina. I'm also going to butcher. Sorry. Who's on her toes like this? Okay? So which exerts more pressure? I have a 1,000 Newton football player or 500 Newton ballerina. Which of these exerts more pressure on the ground? The 1,000 Newton football player or the 500 Newton ballerina? Y'all see that? I missed it in the back. Sorry. What's that called? Tori, what's that called when you go up on your a point? Yes, thank you. All right, just a few more seconds. I'll stop at 32. 32. This goes back to our definition of pressure that we had at the very beginning. Huh? No, the football player is just standing there, but I'm sorry, you didn't see my picture? The ballerina is on her tiptoes, is on point, right? That's what it's called, on point, okay? Standing up on her toes. All right, I'll stop at 58. 58. Okay, very good. B is the right answer. Because remember, pressure is related to two things. It's related to the force and the area. And so if I have a big force, that can cause a big pressure. But if I have a small area, so if A goes down, that causes my pressure to go up. So here, she's just sort of standing on the very tips of her toes, whereas the football player has this very large area underneath his feet. And so his pressure, even though he has twice the weight, he has a lot more area, and so that causes to have less pressure. Right? You'd much rather have a football player step on your toes than a lady in high heels, right? That would be very bad to have them take that little bitty point and step on your toe. All right. So when we talk about pressures in solids, we're going to talk about it in a very similar way, that pressures in solids cause a stress. This is a definition. I'm going to put a box around it. I'm going to put a box around it twice. Stress has the same definition as a pressure. It's force per unit area. So when we talk about stress, we sort of have this anecdotal view of stress, but in physics, stress means a force per unit area. Right? It's a certain pressure that's being acted upon on a solid. It's a physical term, and it has a measurable quantity. It's in newtons per square meter are the units, and that's stress. Now this stress is going to cause a deformation. I know what the deformation is called? It's called strain. Very good. So the stress on a solid causes a deformation, which is called strain. We can measure that in a variety of different ways. So I have this. If I apply a stress to it, like if I stretch it, it will. Well, that's not a very good example. If I have a rubber band. If I have a rubber band, I have this rubber band. I know that you in the back can't see it because it's kind of small, but y'all see it up here? If I apply a force per unit area to it, a stress, that causes it to stretch. You see how I got longer, that rubber band? Can y'all see that in the back? Macy, can you see it? Yeah, okay. So my rubber band, if I apply more force, it causes more strain. Right, so if I apply a stress to it, then I get a greater deformation. The greater the stress, the greater the strain. Likewise, if I have something like this, I can apply stress in different directions, right? Like I can cause a stress in that direction, and it causes a strain that's similar but different. Now, we have something called the elastic limit. If you exceed the elastic limit, what will happen to the object? Right. So you get a permanent. So that would be like doing what to your leg, for example, breaking it. Yeah. So like your bones, they can accommodate a certain amount of strain, but at some point you're going to surpass the elastic limit, and that will cause a permanent deformation. If you exceed the elastic limit, it causes a permanent deformation. And permanent deformation, that's just like Fancy Nancy saying to break. Y'all know Fancy Nancy? Like she says things with fancy words. Permanent deformation is just a fancy way to say break. All right. It's not going to bend back to its original shape. Okay. All right. So we have a few more minutes. I want to go on into fluids in motion. Some of this is going to be on your quiz anyway. So let's go ahead and look at fluids in motion. And then in a few minutes, I'll give you a quiz in about 5 minutes or so. Okay, on stress and strain? Oh, there were 3 things, actually. I'm just going to write them here. You're not actually going to use them. There are 3 ways to accommodate this. Your book just sort of mentions them, so I'm going to mention them here too. Young's modulus. There's no relation to me. This relates stress and strain in one dimension. So it's like the rubber band. The rubber band, if I stretch it, if I apply a certain stress in one dimension, it causes a strain in one dimension. The next was the shear modulus. And this is like a 2-dimensional stress. I can't think of a good example, but I think you could think of it as this, that if I bend this, it's going to cause it to bend, but it's only a 2-dimensional thing. That's not a great example. And then the third is bulk modulus. And this is a 3-dimensional stress, a 3D stress. Good example of a bulk modulus is if, like a balloon, if I compress a balloon, it causes a certain amount of stress, right? If I just compress a material, it causes a certain amount of stress, which causes a strain. I just want to mention those to you, because you might see them elsewhere. You can measure these quantities, which describe how much strain you get for a certain stress, and it's related by this quantity. So like bones, for example, have a certain Young's modulus, and they have a certain shear modulus that describes at what breaking point they have, describes what their breaking point is. All right? All right, let's move on then. Fluids in motion. So which of these look at fluids in motion. The study of fluids in motion is called fluid dynamics. There's all sorts of cool things that go on. And I don't know if you recall, but I said that fluids are anything that flows. Sort of gave this general definition for fluids early on. So, for example, which of these is a fluid? I'm going to list 4 quantities, 4 items here. 1, water. 2, air. 3, Jello. Or 4, wood. So which is it? Is it A, 1 only? B, 1 and 2? C, 1, 2, and 3? D, 4? Or E, all of these? This is which of these is a fluid? Air, water, water, air, jello, or wood? Is it A, 1 only? B, 1 and 2? C, 1, 2, and 3? D, 4, or all of these fluids? Which of these, in the normal sense, would we consider these to be fluids? Though we'll see a very stark example of this next time. Which of these is a fluid? All right, looks like we're picking up another class on this. I'll go to 40 seconds, okay? There's another class using clickers. That's where I get so many students. All right, I'll go to 45. Just a few more seconds. Oh, boy. Look, they're not doing nearly as well as y'all are, okay? Let's see, what's the answer, though? B is the right answer. No. Jello, I would not consider a fluid, because if you just leave it there, like in its normal state, it's not going to flow. Oh, yeah, well, it's water, basically. I understand what you're saying, Valerie, but B is the right answer. Okay, B is the right answer. Jello, I understand. And I'll show you next time something that... No, it's a jiggly thing. It's a solid, right. Yeah, it doesn't flow in the normal state. Though next time... losing control. In control. Y'all don't know that reference? Y'all don't know that? You haven't seen the Muppets? In control. Who says that? Monster, the drummer? Okay. I'll show you an example next time of something that looks a lot like a solid, but it's going to flow just like fluid. It's really cool. The pitch drop experiment, you ever seen this? The pitch drop experiment? It's really neat. I'll show you next time. Let's go ahead and put our business away. You won't need a calculator, just your pencil. So again, the test will be on Thursday. I'll put a seating chart outside the door, so make sure that you get the appropriate seat when you come in. And you will need a what for that test? Right, that's this sort of bluish form. You can get it in the bookstore. Sometimes the SGA gives them away out on campus, or you can just ask your friend. Like if you really want to be a slouch and just bum off of people. All right, but this is just a quiz. So on this, I just want you to write the answer next to the number, okay? So whether it's A, B, C, or D, or E, or T, or F for true or false, just write that next to the number. Is that clear? Okay. I want to start over here. All right, keep your eyes on your own paper, please. It is a 0 if you're cheating in any way. It's just a quiz. Like, you don't want to give up your integrity, right? How much is your integrity worth? It's priceless. No, honestly. Seriously.